In this video, we're going to learn how to solve problems involving reflection of light in physics. Okay, so we are going to look at basically how to calculate problems involving magnification. We also look at mirror formula and how to apply them to solve problems in reflection of light and the rest of them. So ensure you stay to the very end of this video because you are going to learn a lot, guys. But having known that, let's begin with these magnification questions I have here and progress from there. Okay, so the question 1 I have here says the length of a pinhole camera is 12 cm. It is used to photograph an object 60 cm away from the hole and 80 cm high. Calculate the height of the image and magnification produced. Okay, so to begin with, to calculate magnification of light in physics, this is a formula that is applied. Magnification equals V over U, where V is the image distance, whereas the U is the object distance. Okay, so this is I. Okay, now let's bring out the parameters we have for this question. So in this question we have the image distance to be, so it says the length of a pinhole camera is 12 cm. So we have the image distance to be 12V to be 12 cm, and we have the object distance U to be, it says it is used to photograph an object 60 cm, so it's 60 cm. Okay, we also have the object height, okay, away from a hole and 80 cm high. Okay, the object height, which is HO, to be 80 cm, and we now have the image height, which is a HI. Okay, so let's get the magnification first. To do that, just substitute the values for V and U respectively. So if it is going to be M magnification, it's going to be M magnification equals V is 12 over 60. So when we divide through 12 divide 60, we're going to have it to be, okay, 0.2. So it's either you leave it as 1 over, you break it down, 1 over 5 or 0.2. That will be the answer. It does not have a unit. Okay, magnification does not have a unit. Okay, so that's it for magnification. Now let's go ahead and find the height of the image. Let me wipe some parts below. Okay, so to calculate the height of the image, this is the formula we're going to apply. That's image height HI over object height HO, okay, equals image distance over object distance. Okay, so we don't have the image height, that's what we're looking for. So let's impute these three parameters we have in this expression. So when there is, you're going to have HI over our HO is 80 equals, so our V is 12 over our U is 60. So it cross multiply, going to have 60 HI equals 80 times 12. So this is something as 60 HI equals, so 80 times 12 is going to give us 960. Okay, so divide both sides by 60. So this will cancel this. Therefore, our HI will be 960 divided by 60, which will give us was 16 cm. And this will be the image height. So that's it for question 1. Now let's wipe this and solve for question 2. Very, very interesting. Okay, so question 2 says an object of height 40 cm long is placed 0.8 meter in front of a pinhole camera of length 60 cm. What is the magnification and height of image produced? Okay, so let's bring out our parameters. In this question, we have our HO, that's object height, to be 40 cm. Okay, and we have the object distance U to be 0.8 meter. Now, if you check, these parameters for this question too are in cm. Alright, so this one that is peculiar, that is a meter, you convert it to cm. Okay, so if you do, you're going to have to convert this from meter to cm. It's going to be 0.8 times 100. So you multiply by 100. So if you multiply this, it's going to give you 80 cm. Okay, now our image distance V is, okay, say pinhole camera of length 16 cm. We don't have the image height, HI is unknown. So let's begin by finding magnification. As we all know, magnification is image distance over object distance. So the image distance here is what, 16, okay, over the object distance is what, 80. So when you simplify this, we're going to have 16 into 80 will give us 1/5, which is something as 0.2. Okay, there's no unit for it. Now to get the, we have to find the height of image produced, that's the image height. We're going to apply this formula, that's HI over HO equals V over U. So when you substitute the values, we're going to have HI over, our HO is 40 equals, okay, so we have our V to be 16 over, and we have our U to be 80. So when you cross multiply, you're going to have, let me clean this side. Okay, so we're going to have 80 HI equals, okay, 40 times 16, which will give us 640. So to make HI the shortest formula, divide both sides by 80. So this will cancel this. Therefore, our HI will be, this will cancel this 0. So 64 into 8 will give us 8. Alright, so the image height is 8 cm. Okay guys, so this is basically how you can solve this kind of problems involving magnification and finding the height of an image. Okay, so let's wipe this now and look at further problems on reflection of light questions. Okay, so let's wipe everything. Okay guys, so this is question 3 of these problems we are solving. So question 3 says an object is placed between two mirrors. We have entered mirror questions now, which are inclined at an angle of 90 degrees while facing each other. The number of images formed by the two mirrors are, so to get the number of images formed by a mirror, this is the formula you apply. Alright, so this is the formula 360 degrees over n minus 1. Alright, so where n is the angle inclined at the mirror. Okay, so in this question, the angle inclined at the mirror is 90. So you substitute 90 for n below. So if you do it, you're going to have 360 degrees over 90 degrees minus 1. So this will give us 4 minus 1, which will give us 3. So we have 3 number of images formed. Okay, had it been we're having 180 degrees there, it would have been 360 over 180 degrees minus 1 in that order. Okay, so that's it for question 3. Now let's look at question 4. Let me wipe below first before I look at question 4 and 5. Okay, so question 4 says an object is placed 15 cm from the pole of a concave mirror of radius of curvature 20 cm. Calculate the magnification of the image formed. Now I want to say something about concave mirror. I want you to take note of it. Now, a concave mirror has a real principal focus. Okay, hence the focal length is positive. All right. Now note again that it forms either way or virtual image depending on the position of the object. Now if it forms a ray image, then the object distance, which is our u, and image distance, which is our v, from the mirror are both positive. All right. If on the other hand the image is virtual, that means the v is negative. Okay. Now for the situation in which the image distance, that's the v, is positive, together with the object distance, which is our u, being positive as well, then the focal length will also be positive. Okay. Now for such situation, the mirror formula will be calculated using 1 over f, which is our focal length. F stands for focal length. Okay, equals 1 over u plus 1 over v. Alright. Whereas if the image form is virtual, implying that the image distance v is negative, we're going to have the mirror formula to be 1 over f equals 1 over u minus 1 over v. Alright, so take note of this difference. Okay, very important, guys. Alright, so having known this, note one thing, that for mirror formula, focal length can be calculated using f equals the radius of curvature divided by 2. Alright, now if you want to get radius of curvature when it's not given and you have focal length, all you have to do is to times focal length by 2 and get radius of curvature. But when you are looking for focal length and you have radius of curvature, divide the radius of curvature by 2 and you get the word focal length. It's as simple as that, guys. So having known these parameters and this formula, let's go ahead and solve question 4 and 5, and after you can call it a class. So let's write below. Okay, so the question says an object is placed 15 cm, that's question 4, from the pole of a concave mirror of radius of curvature 20 cm. Calculate the magnification of image formed. Okay, now to get the magnification of image formed, we need the image distance and object distance. So in this question, we have the object distance u to be 15 cm, and we don't have the image distance, is unknown, and we are given the radius of curvature to be 20 r to be 20 cm. Now to get the focal length, it will be radius of curvature divided by 2, so it will give us 20 divided by 2, will give us for 10 cm. Alright, now to get the image distance, we're going to apply this mirror formula. That's 1 over f equals 1 over u plus 1 over v. So when you put the formulas, we're going to have 1 over 10 equals 1 over 15 plus 1 over v. Alright, so to make v the shortest formula, so this 1 over 15 will cross over this equality sign and change to negative. Let me wipe this side. Okay, so we're going to have 1 over 10 minus 1 over 15 equals 1 over v. So we find the LCM of the denominator, so we're going to give us 30 v. Alright, so 10 into 30 v will give us 3v. Alright, minus 15 into 30 v will give us 2 v equals v into 30 v give us 30. Alright, so when you do the subtraction, our v, you no longer consider this denominator, so that means our v, which is our image distance, will be 30. Okay, so now that you have gotten the image distance to be 30, to get the magnification, remember we're going to apply, to get magnification you apply v over u, that image distance over object distance. So this will give us our image distance is 30 over our object's distance is 15. So when these two divide each other, the magnification will be what? 2. And that will be the answer to this question. So magnification does not have units. So let's write below now, solve question 5, and after it you can call it a class. Very, very interesting, guys. Hope you're learning a lot. Okay guys, so question 5. It says an object is placed 20 meters in front of a concave mirror of radius of curvature 30 cm. Calculate the position and nature of image formed. Okay guys, if you are really learning something interesting on this video, give this video a thumbs up now, and also forget to subscribe if you are new to the channel. Okay, so to solve this question, let's bring out the parameters. So in this question, the object distance, which is our u, is 20 cm, not meter. Correct it. It's meant to be 20 cm. Let me put it here. Okay, 20 cm, because the unit has to rhyme with the radius of curvature. So it's typographical error, 20 cm. Correct it, guys. Now 20 cm, and we have the radius of curvature r to be 30 cm. We don't have the image distance, is unknown, and we are asked to calculate the position and nature of image formed. Okay, now to calculate the nature of image formed and position, we need the focal length, okay, and the image distance. Focal length is unknown, so to get focal length is going to be radius of curvature divided by 2. 30 over 2 will give us what? 15. Now let's use the mirror formula. 1 over f, okay, equals 1 over u plus 1 over v. So let's substitute. It's going to give us 1 over 15 equals 1 over our u is 20 plus 1 over v. So when this crosses over the equality sign, it's going to change to negative. So we're going to have, let me clean this part. Okay, so we are going to have 1 over 15 minus 1 over 20 equals 1 over v. So you get the LCM. So the LCM will give us 60. Okay, so 15 into 60 will give us that 60v. 15 into 60v will give us 4v minus 20 into 60v will give us 3v equals v into 60v will give us 60. Okay, so when you simplify further, 4v minus 3v will give us, so our image distance will be 60 cm. Alright, so this shows us that we are asked to calculate the image, the position and nature of image form. So this is the position of the image, 60 cm. Alright, so the nature of this image, this is a real image. That's the nature. Had it been we got a negative value, it would have been a virtual image. Virtual image. Alright, so since we have a positive value, this is a real image. When you have a negative value, is a virtual image. Okay, so this is basically how you can solve problems involving reflection of light, revolving around magnification, mirror formulas, and the rest of them. Hope you learned something interesting from this video. If you are new to the channel, once more, be sure to hit the subscribe button now to subscribe to the channel for more videos like this. So like, share, and comment on this video. Tell me how you feel for what you have learned. If you seem to have any specific questions, ask, feel free to leave your question at the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching. See you in my subsequent video.